30 seconds. Nice. You live and you learn. You're always learning something new. No, that's not what I'm trying to do. No. All right, 5, 4. All right. So I have that it is that time. Okay. So we are having class. So these sessions are recorded. Welcome to College Algebra 2 with Professor Phifer, right? So I know we're missing some people, but again, these sessions are recorded, so I figured they will see it eventually. A little bit, as far as introductions, a little bit about me. I'm an alum of Morehouse. I got a Bachelor's of Science in Mathematics from Morehouse in 2006. I earned a Master's of Science in Mathematics. Ooh, dang, I wish we had more people here. Because I want to play a game of two truths and a lie. I got my Master's of Science in Mathematics from Applied Mathematics from Florida Institute of Technology in 2011. When we get more people, if I remember, we'll try to do a two truths and a lie game of that. Let me see. So let's go here. Go to view. Actually, I think seamless is better. So we are here for College Algebra 2. This is Math 102. We have our Teams meeting ID with the passcode, right? Again, we meet on Tuesdays and Thursdays from 6 to 7:15. So this is our synchronous course. I have an asynchronous course that is similar. It's the exact same content. It's just a different delivery method. So when they go to watch this, the main thing for my asynchronous course is getting attendance. Now, you know, my asynchronous students, you all will be doing the same thing as my synchronous students. Again, the challenge with you all is getting your daily attendance. And again, this only applies to my asynchronous course, not the students here currently live in the Teams meeting. For my asynchronous students, be sure that you are doing the weekly discussions. The weekly discussion is already available right now. That's how it gets you all's attendance. For my synchronous students, which are the students that are here now, I see two of you gentlemen. It looks like gentlemen. Not trying to, I don't know people's pronouns and I don't want to get in. For our attendance, I take attendance here in the Teams call, right? So attendance is taken automatically. It logs when you guys come and go, how long you were here. I'm kind of lax a little bit when it comes to engaging as far as, you know, the Teams calls. And originally when I first started teaching remote, you know, I'd be like, okay, guys, what do you think about this? And it would be like, crickets, you know, and I'm like, hey, come on, guys, talk, you got to speak, you know. It used to irritate me, and it still does irritate me a little bit, but I've learned, like, okay, we're remote, just keep it going, right? You can pose the question and open the floor, but if students aren't ready to talk, just give them space and time, right? So that's kind of how I do a lot of things. I just try to keep the rhythm, answer questions. Now, as we go throughout the presentation, if you ever have questions, feel free to keep it to yourself. Kidding, that was a joke. All right. Feel free to unmute yourself to get my attention or type it in the chat and, you know, we can answer it together. Now, this is my first time teaching this course at this institution. So what that means is I don't have my lectures pre-recorded. Idealistically, I could have had my lectures pre-recorded in advance and that way you can use it. So I'm going to be making them fresh from scratch with you all. So I'll try to get out ahead as much as possible. But I usually, now you all, there's a copy, these sessions are recorded, and so a copy is going to be held basically here in Teams in the chat, right? So you can access the chat 24/7. This session is being recorded, and you can access the recording. Now, I do intend to pull this recording, and I'm going to load it to my YouTube channel. Now, my YouTube channel is my main way of communicating with students universally across multiple universities across the world. So that's my central hub. I'll show you how to access my YouTube. It's once you gain access to my YouTube channel, it's definitely a good idea to go ahead and subscribe to my channel and turn on your notifications. So that way, when I start responding to homework questions and, you know, just making different posts, you don't necessarily have to watch the videos, but it's definitely a good idea to at least be aware of what I'm posting. So then you can be like, oh yeah, I had that same question. Let me go check that video, right? Okay. Give me just a moment. Sorry. So again, I am Mr. Phifer. You can call me either Mr. Phifer or Professor Phifer. My office is going to be virtual via Microsoft Teams, and the best way to communicate with me is honestly through my office cell phone. It's like a Google Plus number or whatever. I can receive text messages there. I use it like an office phone, so it's dedicated to my students, right? So I can receive text messages. I can you can call that number, and like, so when you go to start using my office hours, the best thing is like to send me a text like, hey, can we meet in your office hours? And I'm like, yeah, I'm there now, let's log in, right? That's the best thing. My email is firstname.lastname@morrisbrown.edu. I'm not gonna lie, I'm not good about replying to emails, but I still encourage my students to email me anyway, just to have it on file, just to have a record of whatever your concern is, right? But again, for the fastest response, the best thing is to use my office cell phone. You can text me, and if I'm out and about and I just can't reply, I'll reply, but at least I'm aware of it. When I get emails, I get so many emails, I just become numb to them all, right? Then I start missing student emails. So my solution to that is using my office cell phone. Again, it's just like a Google Plus number, but it works. So my office hours are Tuesday and Thursday from 9 a.m. to 11 a.m. via Teams. So like if you want to attend my office hours, you would use this Teams information with that meeting ID and that passcode. And then for our live sessions that meet Tuesday and Thursday from 6 to 7:15, you see it here for College Algebra 2, right? So I know at least 2 of you gentlemen have found your way. And that's the first hurdle, right? It's just showing up, following the instructions. It's not easy, right? It's simple, but it's not easy because, people got stuff going on, life and stuff like that. So our textbook that we're going to be using is College Algebra and Trigonometry, 2nd edition by Abramson. It's an OpenStax book. Now, this content is free to use, right? So one thing that is interesting about the way this course is designed is that all of the content and material is free, right? So let me show you how to access this. If we hop over to Populi, let me see. Let me just go to Populi right here. If we get like 2 more people, if you guys can remind me, I would like to do a game of 2 truths and a lie. Let me see. Okay, so this one is here, right? So if we log into our course on Populi, and to access the book on the left-hand panel where we see, the thumbnail of our textbook, and then we see a dashboard, and below dashboard it says syllabus. If we click on syllabus, on the right-hand panel, it says Algebra and Trigonometry 2nd edition. We click on there, and that's a PDF copy of the entire textbook, right? So it's just a digital copy of the book. It's free. You don't have to buy anything. It's there, right? So there's our e-textbook. So then for our homework, we're actually going to be using MyOpenMath, right? So let me just pull that up really quickly as well. So myopenmath.com right here, MyOpenMath, right? All one thing. And let me log in. You would register as a new student, and I'll show you the login ID and all that stuff. Let me actually show that now. Okay, it's coming up in just a moment. Here it is. So for the MyOpenMath, right? So you go to myopenmath.com. You would register as a new student and then use this course ID and this enrollment key. Now it's probably a good idea to go ahead and screenshot this so you have it for quick reference. So then once you go to myopenmath.com, you insert that course ID and use that enrollment key. Then when you log in, it will look like this, right? So now I am confident to say, I'm happy to say that all of our assignments for the entire semester are available right now, with the exception of our exams, right? And the corresponding due date for each assignment is there, right? So for instance, 1.2 exponents, right? If I click here, notice when I click, it says LP. The LP stands for late pass, right? Which means that you can see that it's due 1 week from today, right? But you can actually work on it past the due date. Now, if you submit it promptly, within the due date, you can earn maximum credit, which is like up to 100% for that assignment. But past the due date, I think I inserted a 5% late penalty for anything that's late. With all of our assignments, that includes homework, quizzes, and exams, we get unlimited attempts, and the system is set to take our highest score. and there's only a 5% late penalty, right? That's huge, right? So unlimited attempts on all assignments. The system is set to take your best score, so whatever your highest score, that's what it's going to send me. And you can work on any assignment late with only a 5% late penalty. So if you submit something late, the highest you're going to earn is a 95%, which is huge. In the past, I used to do a 10% late penalty, and every now and then a student would just still maximize their scores late, and it was okay, you know. As long, and you really have access to this the whole semester, all the way into the end. The only thing that's scheduled for release are our exams. So I think exam 1 covers chapters 1 and 2. So once we get towards the end of chapter 2, exam 1 is going to become available. Exam 2 covers, it looks like, chapters 3 and 5. And then exam 3, basically chapter 6. And then that's it, right? And then that'll bring us toward the end of the course, right? So again, each assignment has the corresponding due date. And on average, we're doing anywhere from 2 to 3 sections each week. Okay. If you have questions, again, feel free to unmute yourself to get my attention or type it in the chat. I am monitoring the chat. Otherwise, we're just going to keep moving and grooving. Oh, is that my asynchronous? Sorry. Let me go to my classes. It's not supposed to be asynchronous. It's supposed to be synchronous. Anyway, it's the same thing anyway. They're a copy of each other. So, okay. So hopefully we're all aboard and we're not all bored, right? So we talked about the book. You know, again, we've already made it into the Microsoft Teams, so that's the first hurdle. We see how to access the free ebook. Also, My Open Math is free. It's just a matter of registering, and that's how we're going to do our homework, quizzes, and exams for the semester. Okay. This course is designed to provide you with the fundamental algebraic concepts and with the necessary skills needed to solve and formulate algebraic problems. This course will also help you to develop your logical thinking and problem-solving skills. You will have the opportunity to apply your prior knowledge and make connections of algebraic concepts to real-life applications. Furthermore, you will be required to communicate mathematical ideas using symbolic and written forms. Topics in this course include laws of exponents, factoring, inequalities, polynomials, roots, linear and quadratic equations, complex numbers, rational functions, system of equations, exponential and logarithmic functions, mathematical finance, system of linear equations and matrices, linear programming, and elementary topics in probability and statistics. Whew, that was fun. This course will provide you with a solid foundation of concepts and skills necessary to advance to statistics or pre-calculus. Okay. All right, I think we're good there. So we talked about how to access the assignments. Again, this is more information on how to register for My Open Math. The main thing that you need for My Open Math is that course ID with that enrollment key. Okay. Okay. Oh, man, we kind of breezing through this. I might have to. Okay, so as far as like positioning yourself for success in this course, to me, I feel like the name of the game is time management, right? I feel like the concepts are simple, but it's not easy if you're not good at time management, right? To be honest, you got to set aside at least 4 hours, 4 hours each day for four or 5 days throughout the week, right? That's just what it takes. It is tedious. I feel like the concepts are simple, but it becomes challenging because it does become information overload. So if you're not good with time management, slowing things down, removing distractions, being disciplined, being consistent, right? Like my favorite time to study, even to this day, especially when I was a student, I did this and I still do it to this day, is when I first wake up. I oftentimes wake up in the middle of the night, it'd be like 2, 3, 4 in the morning, and that's when I would do all my work. Another technique that I would use is like as a student, I did work study. So when I was doing work study, I was sitting at this desk. I was getting paid to sit at this desk for hours. I was working in the gym at Morehouse, and I would just check IDs as student came in and out of the building. So I was like, okay, well, if I'm gonna sit here at this desk for hours on end, let me go ahead and do my homework while I sit here. So while I was at work study, that's when I did my homework. When I got off of work for work study, I was done with my homework. I would go back to my dorm and just relax, either game or go to sleep, cook, clean, whatever it is I wanted to do. Time management, right? And that got me through at least to a master's. Now, I don't have a doctorate. That's another story. I'll get back into that whenever I'm ready. At some point I will. But again, I would encourage each student to devise a plan and really focus on time management. You want to be prepared to set aside about 4 hours a day, 4 to 5 times throughout the week. Living a balanced lifestyle is important. That's part of time management. That means getting proper rest, eating proper food. You know, that freshman 15 is no joke, right? That's gaining the weight. You know what I mean? When you're a freshman, or when you go into college. So routine physical exercise is important. It helps to keep your mind clear. But if we're eating like a lot of processed foods, a lot of sugar, uh, cheese and pizza and stuff like that, burgers and fries, it's going to make our brain foggy, and it's going to make learning that much more challenging, especially if we're not being physically active, if we're not running around, jumping, playing, dancing, laughing, playing. That stuff is important too. It's a balance, so all work and no play makes you crazy, right? So again, time management. That's the main thing I wanted to say there. I feel like you can read through this part on your own. I really don't do the discussions. The main thing now, I do need the discussions for my asynchronous students because that's how I'm going to do my attendance. But for you all, the main thing is really just attending these live sessions here in Microsoft Teams and submitting your assignments on MyOpenMath promptly. Those are the main things. But for my asynchronous students, they definitely need to do the weekly discussions because that's how I take attendance. I need some way to measure, okay, are you guys showing up? So for you all, it's attending these live sessions. And again, these sessions are recorded. Attendance is taken automatically. It logs when you guys arrive, when you guys leave, how long you were here, that kind of stuff. So again, homework is assigned pretty much on a weekly basis. Each week we have anywhere from 2 to 3 assignments. We have a few quizzes throughout the semester, and I think a total of 3 exams throughout the semester. Okay. And then the grading rationale is as follows. So the homework, that's going to be the most abundant material, right? You're going to have a lot of homework. The homework is there to pretty much get you ready for the exam. We have a lot of work, but then notice that the homework has the lowest weight, right? So the homework is really just there to get you ready for the exams. Notice that the exams count for 40% of your overall grade, and then the final exam is 25%. So between those 3 exams and the final, that's 65% of your grade, right? So again, the homework is a lot of work, but it has the lowest weight, but it is the most important thing because again, practice makes what? Hopefully you're not saying perfect, right? Practice makes improvement. Because if practice made perfect, that means you wouldn't need to practice anymore. And if you stop practicing, what happens to our skill level? It goes down, right? So practice makes improvement, okay? But yeah, so the homework is there for you to practice, to get ready, to prepare you for the exams, right? Okay, so let me see. I'm not sure about those exam due dates. Well, I'll touch on the exam dates again momentarily. Again, the grading rationale. So then the grading scale, basically the 90s are A's, 80s are B's, 70s are C's, 60s are D's, and below 60 is an F. At most institutions, officially passing the course is a C, right? Which is, in this case, it's going to be a 70 or higher. Okay, so part of time management, organization is also up there, is important as well. So as you kind of make your way through the content, my recommendation, you have like some kind of folder where you can have a copy of the notes. So when I start taking notes and we start going through the lecture notes, anything that you see me writing, I'll make a copy of it available. It's a little bit challenging because I don't have my lecture notes in advance like I'm used to. So I'm going to be doing that on the fly. I'll try to do them in advance as best I can. So that's a little bit of a challenge. Because it's a little bit better because when I have a copy of the lecture notes in advance, then it's easier for me to send them out to you all. So we'll do the best that we can there. But you definitely want to be organized with your notes, have a copy of the notes. As you go through the homework, any homework that you do, you want to like list the topic, the section or whatever. Have a copy of each question and then any of your supporting work, and put your final answer in a box. And so, copy of the original question, any supporting work, final answer in the box. And the process of doing that, creating your own essentially manuscript, that's how you learn, right? Doing the homework and having a copy. Because if you do it, but then you don't like have a copy of it so you can reference it later in the future, you'd be like, dang, I did that, but I don't remember what I did. I don't remember the details. Versus, oh yeah, I did that. I got it right here. Let me flip to it. Versus, well, I didn't do it, but I have a copy of that person's. Let me use that. This doesn't make any sense. I don't know what to do, right? And I know this is a remote course, but you never know when you're going to be responsible for this content in a proctored environment, right? I can't tell you how many times I've had students, finish my course, graduate, they go to their first job interview, and you know what these companies' favorite thing, the first thing that they give them at these job interviews. I'll give you one guess. Hopefully you're thinking a mathematics exam, right? So they go to the job interviews, and the first thing they give them is a math exam, right? And the applicants that do better on the math exam, they have an edge, right? But if you're in this course and you don't do the work, like you get unlimited attempts, and there's the system is set to tell you highest score. So I mean, obviously you can get somebody else to do it, but that doesn't serve you. You're just going to be wasting your time and money, right? Because if you get out of this course and you haven't learned anything, then again, when you get out in the world, they're not going to be kind. Like if you're trying to apply for a job or something, and or whatever, you know what I mean? It's just going to be a waste of your time and energy, right? Also, there have been cases where somebody finishes a course, they get the credit, they finish their requirements for graduation, they graduate, they get into their job, now their family, everybody's depending on them at this job to for their livelihood. Then it surfaces that they cheated, so they never got the credit for that course. So that means they didn't qualify for their degree, so they lose their degree. Now they got to go back and redo the course to get their credit, right? To keep their job, to keep their livelihood, right? You don't want stuff like that to nip you in the butt. You get unlimited attempts. I do encourage you all to collaborate and work together. In my other groups, I have a lot of students that they'll do a group me. I think a group me is a fantastic idea. You all collaborate. Let me go ahead and make some information available for tutoring, right? Now, I'm not sure that this works, but this is the information from the fall. So what I'll do is pull a copy, and you can follow those prompts, and hopefully it still works, where you can access this free tutoring service, right? So let me pull a copy of this. Copy. I'm gonna just let me have some fake copy. Oh, there it was. Copy, okay. And if I go to our course, this one, I'm gonna post it here. Post, okay. So I just made some information about the free tutoring service. It should still be applicable. You just have to kind of like follow up with it, follow through. And let me actually go ahead and make this available for my asynchronous students as well. This one, and post. Okay. So that way when they watch this, they'll have access to it as well. Okay, hopefully we're all aboard, and we're not all bored. Again, if you have questions, feel free to unmute yourself to get my attention and we can talk about it. Otherwise, we're gonna keep moving. Let me see. So again, attendance. So for my students that are here live in the synchronous course, let me see, attendance will be done. Now the discussions I'm going to use for my asynchronous students. Let me see. If you miss 20% of the class time, approximately 3 weeks, then you will be dropped from the course. That's across the board, right? So 3 weeks, that's like, I think 6 sessions sounds a bit much, but again, 20% of the class time. So if you go into like that 7th unexcused absence, then you'll be dropped from the course, and that can mess with your money, right? Which, a lot of us do not have that wiggle room to just be throwing money around. If you do have that wiggle room to throw money around, you're welcome to throw money my way. It's not going to change anything for the grading or anything, but I'm not going to, turn away a blessing, right? Now, again, for my asynchronous students, for you guys to get your attendance credit, you have to do the weekly discussions. That's the only way I'm going to know that you're alive and well. For my synchronous students, you need to. So right now, I see we still only have 2, but again, now we do have a very intimate group, so I'm okay with that. But again, attendance is taken here in the Microsoft Teams. It's taken live and automatically. Now, for these first couple of days, it's kind of lax because I know we're kind of like dusting off the cobwebs, getting used to everything, trying to find our way. And again, these sessions are recorded, so I know my synchronous students, you guys can pull it in the chat, and then my asynchronous students, more than likely, I'm going to pull a copy of this and load it to my YouTube and make that link available, all right, for you all, so that you all can access it. Okay. Simple thing is, maybe I could just add you to this, and you can access this as well. That might be more simple. Anywho, I'm not gonna worry about it for right now. Okay. Last day to withdraw without a grade of WF is going to be, looks like it's Tuesday, March 14th. No, that's not right. That's not the right date. January, February, March. I think it's March 12th. So it's Tuesday, March 12th. Let me change this here. Tuesday, March 12th. College Algebra 2. Let's do the synchronous one first. Here it is. It's supposed to be Tuesday, March 12th. Is that right? Tuesday, March 12th. $2024. Okay. Ooh, my eyeball. I'm trying to export this. It's a PDF. Come on. Files. Let's see. Spring. Morris Brown. College Algebra 2. Syllabus. Can you just replace? That would be nice if you could just replace. It's not going to replace. Upload. I'm coming, gentlemen. I need to delete both of those. Where'd they go? Okay. Spring. Morris Brown. College Algebra 2. Syllabus. I need to delete both of these. Come on. Select all. Trash. Delete. Okay. Let's try this one again. Right there, upload. Cool. Okay. But you know, you saw the date there. I'll change it on top of it a little bit later. Okay. So I think that's Tuesday, March 12th, right? So I think for your academic career, you're allowed up to 6 withdrawals. So if you try to withdraw after that Tuesday, March 12th date, then it shows up on your transcript as a WF, which is withdrawal failed. But if you do it before that Tuesday, March 12th date, then it's a W. And I think you're allowed 6 W's on your transcript, up to 6. Okay. And this little part here is just an example on how I'm going to calculate the grades. Where's that grading rubric? So when I go to calculate your grades, what I'm going to do, I'm going to take the average of your homework, whatever your homework assignments are, your grades there, I'm going to take their average, and then I'm going to say times 0.15. Then I'll say plus your quiz average times 0.2, plus your exam average times 0.4, and then when we get to the end, plus the final exam average times 0.25. Now, when it comes to grades, I mean, I do the best I can to update your grades periodically throughout the course, but you don't really need those updates. The only grade that really matters is at the end, right? If your grade is one thing, you know, after exam 1, it's going to change after exam 2, right? More than likely. But you get instant feedback as you submit your assignments, right? So whatever your target grade is, as you complete assignments, if those scores are lower than your target grade, then there's no way that the average can be higher, right? So you need to be scoring equal or greater than whatever your target score is, right? So you don't really need your grade to be updated that often. Again, because it changes. It's going to continue to change. Every time you submit an assignment, it's going to keep changing. Whatever score you're aiming for, you want to try to be scoring higher than that. If you submit an assignment and it's not higher than that, you're welcome to do it again. Again, we get unlimited attempts, and the system is set to take our highest score. Okay. So again, if you have questions, feel free to unmute yourself to get my attention, or type in the chat. I am monitoring the chat. Okay. Okay. So we kind of talked about time management. I'll let you read through this on your own. Now, normally I would have you sign this and submit it, but I haven't created a Dropbox or anything for you to do that. And then this is a tentative schedule for what I intend to do on a weekly basis, right? So each row corresponds to each week. And so this week our goal is to get through sections 1, 2, and 1, 3. We went through an introduction. I kind of do want to go ahead and try to do section 1.2. The only thing is the PowerPoint is not made in advance, so I'm hesitant about doing it on the fly. But I need to try. So we're going to go ahead and try to do it on the fly. But at least section 1.2. So again, so this week our goal is to finish through sections 1.2 and 1.3. And again, all of these assignments are already scheduled. When I schedule my assignments in my Open Math, I use this as my rubric, right? And it essentially matches up. If we look at week 8, we see that that's spring break from March 4th through the 8th. And then we pick everything back up on week 9 the following week, and I adjusted my dates and everything corresponding to that. Okay, so this is the goal and the intent for the semester for each week. Let me make a copy of this available for you all, and I'll show you how to access these PDFs. So I'm going to export this to Box, and let me put it in the proper folder. Spring, Morris Brown, College Algebra 2. We could put it in the notes, I guess. Update it daily. And I'll send a copy here. All right. So when this bar finishes, you now have a copy of it. And let me show you how to access it. First, I need to hop over to Box. And let's go to All Files, Spring, Morris Brown. This is College Algebra 2. Okay. Let's go back. Let me share. Link. Copy the link. Okay. So let me make this link available for you all. If I hop over to Populi, let me go to my courses and let's go to you all. All right, so we'll call this PDF box link to, this is a copy of daily lectures. Let me change this, hang on. PDF copy of daily lectures. And this is a box link, there we go. Okay. So in this link, you should be able to pull a copy of things as I post them. All right, let me go ahead and make a link to my YouTube videos. Now, again, they aren't made in advance, so, we're going to do the best we can there. My YouTube channel is called Beautiful Mind Phifer. Let me go to my channel. And I do gaming as well, so you'll find some gaming content in there. Now, I really play like 2 games. Mobile Legends, which is like a 5-on-5 battle royale capture the flag style game, and then Dragon Ball Z Dokkan Battle. Right, those are the main 2 games that I play. I don't really play anything else. Students in the past did try to get me to play, what is it called? I can't even think of the name of it. Not Minecraft, where you run around with the shooter. I can't even think of the name of it. It's the popular one. They doing the dances and everything, but I just never got into it. I want to go to my playlist. Now, I did create a playlist, but it's blank right now just because I have to make it as we go. College Algebra 2, this one. So I'll be loading. I try to load them there, or not try, but you know, as I create them, idealistically, if I can get out ahead, this is where I'm going to put them. Share, and let me copy the link. And I need this for both of my groups. Let me see. Let's see. YouTube. Let's see. Full lectures for College Algebra 2, Morrisboro College, spring 24. Okay, playlists. And again, this is going to be a running playlist. Like I'm going to be updating it as we go throughout the semester. Okay, let me make this available. I need to copy these. Edit the post. Copy. Save. Give me just a moment because I want to make this available for my other group as well. Paste. Post. Okay. And then my groups. This one. This. Edit post. Copy. My courses. Come on. This one right here. Post. Okay. Save or post or whatever. Okay. So we have that. We're going to leave that be. Let me think. So I do, like I was saying, I do want to go ahead and try this section 1.2. I might have to make the PDF later, the lecture, but what my plan was the following, right? So it starts with section 1.2, right? And basically what this is, so did I show you all how to access the book? I think I did. On Populi, right? Where is it? Right here. Yeah. So on Populi, to access our book, on the left-hand panel, where it says syllabus, we click on syllabus, and the book is to the right where it says Algebra and Trigonometry, 2nd edition. So this is published by OpenStax. So that's where I'm pulling this from. So this is directly from the OpenStax. They didn't have PDFs. Now I could probably create a PDF from this content, and I probably will. It just would have been nice if it was already ready to go. Other publishers have those lecture slides ready to go. That is a game changer. So I've been working all day to try to, get something going, but I'll work on it. Oh, I have to work on that later. Okay, let me see. So let's take some time and let's at least try to get through section 1.2, exponents and scientific notation. Okay. So some learning objectives here. In this section, we'll use I will use the product rule of exponents, use the quotient rule of exponents, use the power rule of exponents, use the zero exponent rule of exponents, use the negative rule for exponents, find the power of a product and a quotient, simplify exponential expressions, and use scientific notation. I'll go through this first paragraph. Give me a moment. Mathematicians, scientists, and economists commonly encounter very large and very small numbers, but it may not be obvious how common such figures are in everyday life. For instance, a pixel is the smallest unit of light that can be perceived and recorded by a digital camera. A particular camera might record an image that is 2048 pixels by 1536 pixels, which is a very high resolution picture. It can also perceive a color depth gradations in color of up to 48 bits per pixel. Sorry, I don't know. I might need to eat something. I'm kind of seeing stars. So I'm having a little bit of trouble seeing this, but it's okay. And can shoot the equivalent of 24 frames per second. The maximum possible number of bits of information used to film a 1 hour 3600 second digital film is then an extremely large number. Okay. Using the product rule. Let's look here. So it says consider the product of x cubed times x to the 4. Notice that both terms have the same base, but they're raised to different exponents, all right? So when we multiply expressions with the same base with different exponents, long story short, we're just adding the exponents, right? X to the power of 3, what does that mean? X to the power of 3 means x times x times x. X to the power of 4, what does that mean? That means x times x times x times x, right? So x to the power of 3, we write out 3 factors of x times 4 factors of x. So in the end, we have 7 factors of x. So then it's just x to the power of 7, right? So x to the power of 3 times x to the power of 4, again, we just add the exponents, is going to be x to the power of 7. Okay? So that's the product rule for exponents. When we have a to the power of m times a to the power of n, when they have the same base, we just add the exponents. Okay? So we have the product rule. Sorry, I'm still like, I think I need to drink something. Yeah, I'm just getting old. I'm struggling to see. So for any real number a and natural numbers m and n, the product rule of exponents states that a to the power of m times a to the power of n is going to be a to the power of m plus n, right? So that's the exponent, that's the product rule for exponents. We basically just add the exponents, okay? So we have this example. Using the product rule, write each of the following products with a single base and do not simplify them further, right? So the first one, we have t to the 5 times t to the 3. That should be what? T to the 8, right? We have negative 3 to the 5 times negative 3 to the power of 1. So that should be negative 3 to the power of 6. And then the last one, 7 to 3, x to the power of 10. All right. So we see the 8. We see the 6. And I think we see the 10. All right. Oh. Give me just a moment. Okay. So we saw the product rule for exponents. So now we want to look at the quotient rule for exponents, and it's a similar thing, right? So notice if we look at y to the power of 9 divided by y to the power of 5, we have 9 factors of y divided by 5 factors of y. So then 5 of the y's on bottom cancel 5 of the y's on top, and that leaves us with a total of 4 y's remaining on top, right? So when we say a to the power of m divided by a to the power of n, we subtract our exponent. So it's going to be a to the power of m minus n. Okay. So the quotient rule for exponents, for any real number a and any natural numbers m and n such that m is larger than n, the quotient rule of exponents states that a to the power of m divided by a to the power of n equals a to the power of m minus n. So we subtract the exponents. So when we're dividing exponents of the same base, we subtract the powers. When we're multiplying exponents of the same base, we add the powers. Okay. So this one should be straightforward. 14 minus 9 should be 5. You see it there. 23 minus 15 is what? 8. So it should be t to the power of 8. You see it there. Z times the square root of 2. 5 minus 1, it should be to the power of 4. And you see it there. Okay. Okay, power rule of exponents. So we say a power to another power, right? If we look at this example at the bottom of the screen, we have x squared to the power of 3. That means we have 3 factors of x squared. But what is x squared? X squared is 2 factors of x, right? So we have x times x times x times x times x times x. So at the end, we're going to have a total of 6 factors of x. Let's do that one more time. So we have x squared to the power of 3, right? So x squared to the power of 3 means we have 3 factors of x squared. So we have x squared times x squared times x squared, right? But then x squared is 2 factors of x. So we have x times x times x times x times x times x. So ultimately, we have a total of 6 factors of x. So long story short, when we say a power to another power, just like Bebe's Kids, we don't die, we multiply. Now, that kind of shows my age a little bit because I'm pretty sure you guys don't know what Bebe's Kids are. Hilarious movie, raunchy movie when I was younger. These little bad kids, Bebe's Kids, bad kids, running amok. This adult male figure is trying to like take care of this other girl's children. These kids are crazy. They're like, we don't die, we multiply. You know. So here, when we say a power to another power, we multiply. Okay, so we multiply the powers. Okay. So the power rule of exponents, when we say a to the power of m to the power of n, ultimately we're going to have a to the power of m times n. So the product rule, we add the exponents. Quotient rule, we subtract the exponents. Power rule, we multiply the exponents. Okay, so hopefully this is making sense. Okay, so let me show and hide. Okay, cool. So this one asks us to write each of the following. You know what? This has a decent flow. Only trouble is I'm not writing. You know, that's the only thing. But I think I can pull a copy of this and just work with it. Sorry, and I'm still kind of seeing stars a little bit. Let me get some water. I've been trying to like nurse it while I talk. I've been honestly saying a lot of this with my eyes closed. And I just gotta glance at the screen as needed. Give me just a moment. Woo. I probably ate too much salt or something. See, that unhealthy is important to be balanced, right? I'm speaking from experience, you know, because I know what it's like when you're like unbalanced and the effects it has on the body. Ah, yummy, yummy water. Ah. Okay, so using the power rule, right? So we have x squared to the power of 7, right? So we have 7 factors of x squared. Long story short, 2 times 7, that should be x to the power of 14. You see it there. 2t to the power of 5 to the power of 3. So it should be 2t to the power of 15. Now, I think trying to do 2 to the power of 15 is going to be some astrologically large number. So we should be able to leave it as 2t to the power of 15. All right, you see it there. We got -3 to the power of 5 to the power of 11. So ultimately, that's going to be -3 to the power of 55. Okay. And again, if you have questions, feel free to unmute yourself to get my attention or type in the chat. I am monitoring the chat. So notice I'm not writing anything. This is actually like a digital copy of the textbook, and I'm just kind of going through the textbook. Okay. So, you know, when you pull a copy of the book, you already have all this stuff. Ooh. Let me see. Using the 0 exponent rule of exponents. Now, that looks like a typo. So we have t to the 8 divided by t to the 8. We have 8 factors of t divided by 8 factors of t. So then everything is going to cancel. So then it cancels out to 1. All right, so t to the power of 0 equals 1, right? Yeah, definitely. When I think about the things I ate today, I definitely ate too much salt, and I know that's why I'm feeling like this. Okay, so let's see. So the 0 exponent rule of exponents for any non-zero real number a, the 0th exponent rule of exponents states that a to the power of 0 equals 1. Right, so a to the power of 0 equals 1, as long as a is a non-zero. Okay, so simplify each expression using the 0 exponent rule. I'm going to go ahead and show how the solutions. Okay, so a should be 1. Okay, Let me see, for B, the x to the 5s are going to cancel. So then 1 times -3 is just going to be -3. Okay. Let me see, for C, let me look at it here. J squared K. Okay, so on bottom, we have J squared K to the power of 1 times J squared K to the power of 3. So that 1 and that 3, we add those to become a 4. And then you have J squared K to the power of 4 divided by J squared K to the power of 4. So that one ultimately is just going to be a 1. Okay. And then the last one, we have the RS squared divided by RS squared. So that should just be 5. Okay. Okay, so I'm gonna leave that. I'm starting to feel a little bit better. There we go. Yeah, I definitely ate too much salt. I had been sick for like a couple of weeks over the break. Just, random stuff. Part of it was because there was this like bookshelf, I guess, that I had been neglecting to clean. I cleaned everything else, like the floor and everything, but this bookshelf, I guess, for whatever reason, I was ignoring it, and whatever dust was on that thing was like killing me. And it wasn't like I finally got a suggestion like, hey, you might want to clean that bookshelf. I cleaned it, and then I stopped being sick. It was so crazy. So I had gone an extended period of time without like eating, and then not really, but so then I guess now that my appetite is back, I went ham on like a bunch of like unhealthy stuff like chips and things, and now I'm paying for it again. I was like, God, you're like, please. Every time I fix one thing, something else goes crazy. I'm like, man, but that's my fault because again, I'm not eating properly, and now it's catching up to me, so I have to like that with it. Okay. Negative rule of exponents, right? So when we did the quotient rule earlier, notice that our numerator was larger than the denominator. So we always, when we did our subtraction, we finished with a positive exponent, right? So now we want to see, well, what happens or what do we mean when we do a negative exponent, right? What happens when we do a negative, right? So in this example, we have this h to the power of 3 divided by h to the power of 5. So we have 3 factors of h on top, 5 factors divided by 5 factors of h on bottom. So 3 of the h's on top cancel 3 on the bottom, and we're left with 1 over h squared. So if we were to simplify the original expression using the quotient rule, right, we would have h to the 3 divided by h to the 5, which gives us h to the negative 2. So what this means is that h to the negative 2 is equal to 1 over h squared. So a negative exponent basically flips the fraction. So putting the answers together, we have h to the negative 2 equals 1 over h squared, all right? So this is true for any non-zero real number. So a to the negative n equals 1 over a to the n, right? Negative exponent basically turns it into a fraction. And vice versa, right? A to the n equals 1 over a to the negative n. Again, the negative exponent just flips the fraction. Okay. So we have this negative rule of exponents. For any non-zero real number, a, and the natural number n, the negative rule of exponents states that a to the negative n equals 1 over a to the n. Okay, what's the time? Cool, we're almost there. We don't have much more. So as soon as we finish this section, if we can finish this before time is out, we'll call it a day. Let's work through these. I'm going to show and hide. So we have theta to the power of 3 divided by theta to the 10. Let me see. Write each expression with a single base. Do not simplify further. Write the answers with a positive exponent. So if we say 3 minus 10, we're going to get theta to the power of negative 7. So that means we're going to write it as 1 over theta to the power of 7. You see it there. Now on top, we have z to the power of 3. On bottom, we have z to the power of 4. 3 minus 4 is a negative 1. So b is going to be 1 over z. You see it here at the bottom of the screen. Okay. Let me see. We have 4 minus 8 gives us a negative 4. So we're going to have 1 over negative 5t cubed to the power of 4. Right? You see it here. Ooh. Sorry. Give me just a moment. Yeah, definitely ate too much salt today. Give me a second, guys. Siri, change the light color to soft white. Sorry. Hey, Google, change the light color to soft white. Okay, let's see. So write each of the following products with a single base. Do not simplify further and write answers with positive exponents. Okay. So for part A, we have b squared times b to the negative 8. So when we multiply, we add the exponents, right? So 2 plus negative 8 is going to be negative 6. So if we're going to have b to the negative 6, that's going to be 1 over b to the 6. And you can see it all typed out here. Okay. So now, again, if we're multiplying, that means we add our exponents. 5 plus negative 5 adds up to 0. So negative x to the power of 0 should be a 1. So that one should be 1. Okay. So we have a negative 7z to the power of 1 divided by negative 7z to the power of 5. 1 minus 5 is a negative 4. So negative x, when it flips, it becomes 1 over negative 7 to the power, negative 7z to the power of 4. Oof. I'm still trying to like close my eyes, trying to just give my body a chance to like, you know, I definitely ate too much salt. I noticed why I'm feeling like this. So I kind of need to flush my body with like fruits and, you know, no salty things. Finding the power of product. Okay, that's fine. I kind of just want to work an example here. Let me see. So it says the power of a product rule for exponents for any real numbers a and b and any integer n. The power of a product rule of exponents. If we have ab to the power of n, we can rewrite that as a to the power of n times b to the power of n. Okay, that's fine. All right. Let me go ahead and show and hide. Okay. So in part A, we have ab squared to the power of 3. So that means we have 3 factors of ab squared. So ultimately, this is going to be a to the power of 3 times b squared to the power of 3. So a power to another power, we multiply. So ultimately, that's going to be a cubed times b to the power of 6. And you can see it all here. A cubed b to the 6. I don't want to do 2 to the power of 15, but it should be 2 to the 15 times t to the 15. So again, you can see the large number there, 2 to the 15. So that's where you would use your calculator. We got about 10 minutes. I'm trying to get through this section. I think I'm going to leave the rest of those as an exercise for you, just in the interest of time. Okay. Let's work an example here. So the power of a quotient, if we have a divided by b to the power of n, we can rewrite that as a to the n over b to the n. It's kind of like distributing, you know, it's similar. Okay. So for instance, if we work the first couple of examples, so this is going to be, so part A is going to be the same as 4 to the power of 3 divided by z to the 11 to the power of 3. 16 times 4 is 64 divided by z to the power of 33. 64 divided by z to the power of 33. So in part B, that should be p to the power of 6 divided by q to the power of 18. You see it there. Let's do one more. Negative 1 to the power of 27. If we do a negative to an odd power, it should remain negative. And then that's going to be 2 times 27, which is 54. So it's going to be a negative 1 over t to the power of 54. Okay. I'm going to leave the rest as an exercise just in the interest of time. So notice I'm not writing anything. So you have a copy. Like this is basically coming straight from the textbook. So you have to use that. And, you know, but again, our session is being recorded. This one we kind of do need to write out. All right, so 6 to the power of 3. 36 times 3, 63 is 180 plus 36, I think it's 216. 216 m to the power of 6 n to the power of negative 3. 216 m to the power of 6, right? So I said 6 to the power of 3, we got 216. We said m squared to the power of 6 became m squared to the power of 3 became m to the power of 6. N to the negative 1 to the power of 3, n to the negative 3. So let me see for B. So if we're multiplying those, we add the exponents. That's going to be 5 plus a negative 7. So it's going to be 17 to the negative 2. So 1 over 17 squared, whatever 17 squared is. All right. So 1 over 17 squared or 1 over 289. I'm going to leave the rest as an exercise just in the interest of time because we're running short on time. Let me see. Let's look at this real quick as best we can. So recall at the beginning of the section that we found that the number is 1.3 times 10 to the 13 when describing bits of information in a digital image. Other extreme numbers include with the human hair, which is about the width of a human hair, which is tens, hundred thousandths, 10,000, hundred thousandths, 500 thousandths of a meter, and the radius of an electron, which is about that number, right? How can we effectively work, read, compare, and calculate with numbers such as these? A shorthand method of writing very small and very large numbers is called scientific notation, in which we express numbers in terms of powers of 10 or exponents of 10, okay? Let me see. To write a number in scientific notation, move the decimal point to the right of the first number in the digit, the first digit in the number, and then write the digits as a decimal number between 1 and 10, and then count the number of places and multiply the decimal number by 10 raised to some power of n, okay? Let's see if we can work an example or two. All right. So a number is written in scientific notation if it's written in the form of a times 10 to some power n, where the absolute value of a is some number between greater than or equal to 1 but strictly less than 10, and n is an integer. Let's work an example. Okay. Show or hide. Okay. So write each number in scientific notation. The distance to the Andromeda galaxy from Earth, let me see, 1,000, million, billion, trillion, quadrillion, quintillion, hextillion. I think because the 6 is the 6th one, right? So if we were going to write this in scientific notation, the decimal, if we move the decimal to the left, let me see, 3, 6, 9, 12, 15, 18, 21. So we're moving the decimal to the left 22 times. So then the decimal is going to be 2.4 times 10 to the power of 22. 2.4 times 10 to the power of 22 meters, right? The diameter of the Andromeda galaxy, let me see, 3, 6, 9, 12, 15, 18, 21. So then 1.3 times 10 to the power of 21. You see it there. The number of stars in the Andromeda galaxy, 3, 6, 9, 12. So 1 times 10 to the power of 12. Okay. And again, just in the interest of time, I'm going to have to leave the rest as an exercise there. Observe that if the given number is greater than 1, as in examples A through C, the exponent of 10 is positive. If the number is less than 1, oh, I wish you had done those. I'm still going to have to leave those as an example because we're running short on time. So we looked at some examples on going from a large number, converting to scientific notation. Now we want to look at some examples of converting from scientific notation back to the numbers, right? So here we're asked to convert each number in scientific notation to standard notation, okay? So notice we have 10 to the power of 14. That's going to be a really large number. So that means we're going to move our decimal to the right. So our number is getting bigger and bigger and bigger. So in part A, we move the decimal to the right 14 times. Right? Just if you just move it, you can get it there. 14 times, we get this. Notice in B, the number is getting bigger, so we move the decimal to the right 6 times. So a negative 200,000, 2 million, 6, right? I got it off, but that's okay. Notice in C, our 10 is 10 to the power of negative 7. So that's a really small number, so that means we're going to move the decimal to the left 7 times. So long story short, we're going to have 6 zeros in front of the 7. It's going to be 0.000000791. Right there. 6 zeros, 1, 2, 3, 4, 5, 6, 7, 9, 1. And then the last one, we move the decimal to the left 12 times. So we're going to have a total of 11 zeros to the left of 8. So it's going to be, negative 0.0000000000805, right? 11 zeros. Right? I was using my fingers to count. Okay. So again, the main takeaway there, we had the negative powers of 10. So that means we're talking about a really small number. So the decimal moved to the left. When we had the positive power of 10s, we're talking about really large numbers. So the decimal moved to the right. Okay. So we can use scientific notation in applications. Perform the indicated operations and write each answer in scientific notation. Let me see something here. There it is. Okay, let's keep going. So in this case, like if we're looking at part A, we would say 8.14 times 6.15. Siri, what's 8.14 times 6.5?
14 times 6 is 84.
Siri, what's 8.14 times 6.5?
8.14 times 6 is 48.84.
She's still not getting it. I'll try one more time. Siri, what's 8.14 times 6.5?
14 times 6 is 84.
Siri's let me down. All right. Let me try another one. Hey, Google, what's 8.14 times 6.5?
8.14 times 6.5 is 52.91.
So she said 52.91. So notice that 52 is not in scientific notation, right? 52.91. So we have an extra 10 in there. Now we have 10 to the 7 times 10 to the 10 gives us 10 to the 3 because we add the exponents. Plus that extra 10 from that 52. So it becomes 10 to the 4. So it should be 5.291 times 10 to the 4. See, there it is right there, okay? I'm going to have to leave the remainder as an exercise. I kind of want to do the division one, but I'm going to have to leave that for you. And again, we have it written out here in the text, so you can kind of follow that to get some ideas. I'm just trying to get to the end. I'm going to have to leave that one. Okay, I think we're there. Okay, cool. So yeah, that brings us right to the end. Okay, so we were able to make it through this section. It wasn't PowerPoint presentation, but we were able to touch on the main things that I would have liked to touch on anyway. So some highlights. I would encourage you all to collaborate, to maybe start a group me or something. I put some information in Populi on how to seek out a free tutoring service. So it's a good idea to follow up with that. I put information on how to access my YouTube channel. So when I start replying to like students' emails and students' questions about homework and stuff like that, well, just questions about homework, I usually post them on my YouTube channel. So, you definitely want to be subscribed with your notifications turned on. Our assignments are available on MyOpenMath, right? So we have information on how to access that for free. That's how we're going to do our homework quizzes and exams for the semester. Um, so for you all, you got your attendance by joining my live session. For my asynchronous students, I can't stress this enough. Be sure to be doing the weekly discussions to get your attendance, right? If we miss 2 weeks of attendance, then we could be booted from the course, right? 2 or 3 weeks, something like that. Are there any burning questions before we go our separate ways? All right, going once, going twice. Forever hold your peas and rice, okay? If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care. See you next time. Peace.